next part of the note. Nope. Okay, so matter. Anything that has mass and takes up space. This includes all things that can be seen, tasted, smelled, or touched. Okay? Almost anything that you can observe with your senses. Okay? Taste, touch, smell, sight, sound. Okay? All of those things would be considered matter. Okay? Now, some things are really easy to classify as matter. Solids, for example. Okay? This whole pile of toys. All of that is pretty easy to understand as matter. But some things are a little more difficult. Okay? For example, smoke. All right? Smoke is something that you can see sometimes. Okay? You can smell it. You can't really feel it. Okay? But you can smell it. So that means that it does have some physical properties. It is some kind of matter. Okay? Air is matter. Okay? Sometimes you can smell air. Sometimes you can see the effects of air, but it's hard to touch air or kind of see it and describe it. Does that make sense? It's clear. It's visible. All right? Think about gases. Raise your hand if you're familiar with diffusers or essential oils. Okay? Good. When your mom or whoever turns on the diffuser in the corner, right, can you see the smell as it comes through the room? No. You can see it. You can see the concentrated part as it's coming out of the diffuser.
That's what she said.
Can you see the vapor?
Yeah.
You can see it as it comes out of the diffuser, right? But let's pretend, for example, let's say I stand up here in this corner and I turn a diffuser on. Okay, I put like a lemon smell in there. Who's going to smell it first? Connor. Who will smell it last? Caleb or Sophie.
Somebody.
Okay, someone across the room. By the time it gets to Sophie, can I see the vapor? No. But is it still there?
Yes.
Yes, it is still a gas. It is still matter. You just can't see it or touch it or feel it. Does that make sense? Okay? But anything that has mass or takes up space can be considered matter. The only things that are not included in matter are types of energy, okay? Including things like heat, sound, or light. Most everything in the universe can be classified into one of those two categories, matter or energy, okay? Energy is basically anything that doesn't have mass or doesn't take up space. It's going to be energy. Those are going to be things like the light, heat. Now, the objects that produce those things typically are matter. A light bulb is matter, but the light that comes from it is energy. Does that make sense?
Yeah.
Okay, so for matter, it has to have mass and take up space. You got to be able to measure it. So this describes all the physical substances around us: the table, our body, a pencil, water, etc. Now, all matter can also be classified or grouped based on its physical properties. Okay? We've mentioned classification before, which means to put things into groups based on characteristics, right? If I have that big pile of toys that was in the picture before this, I could classify those based on all kinds of things. I could classify it based on color. Okay, put all the blue toys over here, all the yellow toys, all the green toys, all the red toys. I could classify it based on size. I could classify it based on weight. I could classify it based on how old the toy is. These are the ones that are brand new. These are the ones that are older. Okay? A physical property is what we use to classify or group pieces of matter. Okay, which begs the question, what is a physical property? A physical property is anything you can observe or describe about an object. To observe it means to look at it with your eyes. Okay? I notice that it is this way. That's an observation. Now, there are tons of different types of physical properties, including mass, volume, mass, volume, weight, size, color, texture, odor, etc. Okay? Bella.
I don't get why, even though it's an energy, why heat and
You can see the effects of light. You cannot actually see the light. Can you see heat? You can feel it, right? Can you measure how big the heat is? Okay, can you measure how much space the heat takes up? No. That would be, that's why it's not considered matter. Same thing with light. Can't measure how big it is, can't measure how much space it takes up. Sophie? Yes, the sound of your voice is energy. The actual objects in your body that make the sound, those are matter. Does that make sense? Connor?
Sometimes you can actually see heat coming from like cars with the exhaust. You can see the air coming out in waves.
Yeah.
You can actually see heat.
The
in
heat.
Air.
Oh, I see what you're saying. The heat coming out in waves. You're not actually seeing the heat. You're seeing the effects of the heat on the molecules, on the light waves. But you can see the effects of it. Yes. Okay? All right. So let me describe this for you. Physical properties. Let's say I went to my friend's house. Okay? And they said they had this really cool pantry, right? They had this really cool cabinet full of all this kinds of food. But it's one big mess. Okay? And my friend says, hey, you can stick your hand into our pantry without looking and grab one item. I say, okay, well, I know they have gummy bears, and I love gummy bears. How am I going to make sure that the one I pick is a gummy bear and not any other kind of food? Bella?
Well, it's in the packet, which would help if it's like just gummy bears. I guess in like a Ziploc bag, you can feel the bag and feel the shape of the gummy bear again.
Okay, so I can tell it's in what I would feel for something that's in what kind of shape?
Sort of bumpy.
Bumpy because it's shaped like a what? A bear. Okay, I'm gonna feel for something that's shaped like a bear. What else? Caleb? It's what? Something sticky. Good. If it's unwrapped, I could feel it. If it's sticky, luckily it might be a gummy bear. What else am I gonna feel for? Ethan H?
Well, you could technically find a cheap, but this one here you can organize it and then stick your hand in it.
Okay, without doing that, what else am I gonna search for?
You could search. You could search for like. You could like smell. You could smell it.
Okay, what's it gonna smell like?
It's gonna smell sweet and sour.
Sweet and kind of sour, maybe a little fruity. Okay, what else am I gonna feel for? Reagan?
Not just like feel for, but like what kind of feel for the weight of it. Of maybe you memorize this specific weight because if you love them so much, then of course you're gonna memorize it.
Okay, in general, how am I gonna make sure I'm picking a gummy bear and not like a big thing of squishy honey?
Maybe the size.
The size? What kind of size am I looking for? Big, small, medium?
Depending on the type of ones you get, because there's little packages sometimes of them. Yeah. I still have this huge thing of gummy bears, more like a but it's still in there, and it's like this big.
Okay, but the actual gummy bear, what is the size of that?
Oh,
Tiny. Okay, I'm looking for a small, sticky, bear-shaped, fruity-smelling object. What else?
it's squishy.
It's squishy. Thank you. Okay? If I'm feeling around to make sure I want to get the gummy bear and not anything else, I'm looking for something that's squishy, maybe a little bit sticky, smells fruity, it's small in size, and it's bear-shaped. All of those are physical properties of the gummy bear. That's the texture. That's the odor. That's the size. That's the volume. That's the weight. You see what I'm saying? Okay? Anything you use to describe the object, basically, is a physical property. Okay? So, let's practice. We're going to look at a few pieces of matter, and I want you to tell me some physical properties of that matter. Don't tell me what the object is. Give me physical properties of it. Let's pretend I have no idea what this is. Reagan?
It has more of a yellow color at the center, and as it spreads out, the more of white.
Very good. The color of it. It has a yellow color in the middle, and as it spreads out, it gets white around the outside. What else? Hannah? The petals, so they feel soft, they look soft. They look soft, but what do they feel like? Okay, they do. They feel soft. Has a soft, kind of smooth, light texture. Good. Parker?
You could feel if like all the petals like branching out of the middle of the flower.
Okay, so the shape of it has some petals or circular type objects branching out from the middle spot. Good. Sophie?
Does that smell or taste good?
Good. The odor, not good. Good is an opinion. What does it smell like?
Probably. I don't really know. I like eating.
Shh. What kind of odor does it give off?
Probably flowery.
A flowery, sweet kind of odor. Good. One more, Caleb. It's small? Okay. We need to be a little more scientific than that. So you can't obviously measure it, but let's give it some kind of unit. Centimeters, inches, feet, miles. And take a guess at what you think it is. Pardon? About 1 inch. Good. One particular part of that would be about 1 inch across. Works for me. It's not that big. Okay? Good. Those are all physical properties of that matter. What about this piece of matter?
Now I'm hungry.
Think about size, weight, texture, odor, color, the state of matter.
Tastiness.
Connor, what do you think?
It definitely tastes good.
Okay, good is an opinion. You gotta be scientific. It tastes what?
It tastes cheesy, meaty, lettucey, tomatoey.
Okay, let's go with beefy. It tastes beefy or salty. Okay?
Beefy and salty.
All right, let's taste. Moving on. Nathan?
It is a food.
Okay, it is a food. So what are some physical properties of food?
Edible.
It is edible. There we go. We'll say that. It's edible. Trinity? It's made of multiple different foods. Okay, so it's made of multiple different parts. Okay? Landon? It's rough. Which part of it is rough?
Except for the cheese and tomatoes from the.
Okay, good. So especially the top part of the bun, right? Well, you could say it has like a rough or a bumpy texture. Is usually what we end up saying. Ethan H.
It's probably about maybe 4 inches tall.
About 4 inches tall. Very good. Ethan A. It's squishy. Good. Hattie.
Kind of light, but it's like light, kind of.
Okay, so give me an approximate measurement. Let's usually mass is measured in grams. 1 gram is about equal to 1 paperclip. So kind of guess how many grams you think that would be. 30 grams. Okay, probably gonna be a lot more than that, but I like the thought. About 30 grams. We'll say that. One more. Hattie, not Hattie. Hannah. Okay. Let me ask you this. What state of matter is this? It is a solid because if I take it and put it in a container, it will maintain its size and shape. Now, there is a part of this that we could say is a different state of matter. Kayla, what is that? The cheese. What state of matter is that? Liquid. Yep. Not a pure liquid, but it's melting to where it's more liquidy. Okay? No. One more, and then we're going to move on. This piece of matter. Reagan?
Its texture is probably going to be smooth because of the warmth of your hands warming it up.
Okay.
But if you get to a really icy part, it's probably gonna be a little rough.
Okay, could be smooth, could be rough, depending on the part of the ice you're touching. Kayla? Very good. Temperature is a physical property. That it's cold. What kind of temperature would you think? Tell me in degrees Celsius. got to be at least 0 degrees Celsius if it's frozen. Very good. Trinity? It looks like a solid. It's in a solid state of matter. Good. Now, this part, the parts that's melting, that's in a liquid state, but we're talking about the actual ice. So very good. Ethan A? It's 3D shaped. Okay. It is 3-dimensional. Davin?
It is transparent.
It is transparent. Very good. That would be the color of it. And on and on and on. Okay? Now, typically, I like to do this one too. What about this piece of matter? What are some physical properties of that piece of matter? You better be nice. Hannah? Tall. Okay. How tall? You gotta give a measurement. 5 foot 9 inches. Very good. Davin? It is living. Good. That would be a physical property. I didn't think I would be living much longer after that, but that was after my brother and I went on. We did a 14,000-foot hike in Colorado. No, I almost died, but I was very tired. Yes.
The shirt would probably be like cloth.
Good. The shirt would have like a smooth cloth kind of texture. Good. Landon? Sure. Has long hair. Okay.
Second is
Strong.
Yeah.
Got muscles. Good. Okay. So, what state of matter? Caleb? I am a solid. Absolutely. Okay.
He's a liquid.
So, now that we've had some practice naming physical properties, we're going to discuss physical properties in particular. Okay? The next couple of days, we're going to walk through. We're going to learn about several physical properties. The first physical property we're going to look at is one of the most obvious. That is the state of the piece of matter. Okay? There are 4 possible states of matter. There are some more minor ones in between, like oobleck, for example. You guys know what oobleck is? Okay, from the fun fair. That is it's called like a semi-solid, semi-liquid. Okay, but in general, there are 4 main states of matter: solid, liquid, gas, and then plasma. We're gonna learn about plasma in a little bit. Okay. First one we're gonna look at is solid. Definition for solid is this: a solid is a state of matter in which the matter has a definite volume and a definite shape. Now, the word definite means unchanging. Okay, it is absolutely sure. It's unchanging. All right? So, a solid has a definite volume. It has a certain size that doesn't change. And a definite shape. It has a certain shape that does not change. Okay? Now, think about it like this. If I took 1 penny and I put it into a cup, that penny will have a certain size and a certain shape, and it will not change just because I put it in the cup. If I take the penny and then put it on the floor, it will have the same size and the same shape. It will not change just because I took it out of the cup. Okay? That is a very obvious but very scientific definition of a solid. No matter what you do to it, unless you add some kind of force, right? If you take a penny and smash it with a hammer, of course it will change size and shape. But that's because you added energy to it. Okay, you know what I mean? Okay? That's because you added energy to it. In general, if you leave the object alone, it will maintain size and shape. Okay? So, I gave you 3 examples. Penny, cinder block, rubber wheel. You can pick any example. Could be one of mine, could be one of yours. But write an example of a solid in your notes. Connor, you have a question?
Yes. What is the one physical property is called the? I didn't get that.
State of matter. Reagan?
When you have sandstone, it's basically a solid made up of different solids.
Yes.
Because it's all little pieces of sand stuck together to make one whole solid.
Mm-hmm.
But then when you take one single piece of grain of sand, then it's all that.
Apparently that's true of everything, except for elements.
True.
But technically, you could take every single piece of matter and break it down into smaller pieces of matter. The objects that make it up.
Kind of sushi.
Kind of. All right. No. Landon? If you take the Play-Doh and you put it into a cup, will it maintain size and shape without applying force? Yeah. It's kind of a little bit of both. If you ask me, I would say it's a solid because it's not necessarily the same as a liquid. Especially once it dries out, then it's for sure a solid. Yeah, no, it's a good question. Yeah. Well, I'll give you 1 second, okay? All right, liquid. That's the next state of matter. A liquid is a state of matter in which the matter has a definite volume, it has a certain size or amount, but it does not have a definite shape. Okay? Again, I told you yesterday, if I took a 16-ounce can of Coke, or 8-ounce can of Coke, whatever it is, and I poured it into a tall, skinny glass, it will take this tall and skinny shape, right? It will fill up a tall and skinny glass. But if I take that same 8 ounces of Coke and pour it out on the floor, I will still have 8 ounces, but now it's in a totally different shape without me applying any force to it whatsoever. Okay? That's the definition of a liquid. So I gave 3 examples, water, Coke, and liquid paint. You can give one of those or a different one. Totally up to you. Ethan H?
Would a flag be considered a solid? But because it doesn't really have definite shape.
Definite shape. It does have a definite shape, but that shape is not like firm. That makes sense. It's not going to all of a sudden like it's still the same rectangular shape, but it will all be folded up into whatever container it's in.
Okay. So right can I put that down?
Yes.
What's strange with liquids is that depending on what you're saying with when you pour this amount of cup of water into a skinnier cup of water, you pour it all in there, it's kind of hard to pour every single bit of it in there because most of the water droplets, they just like break off.
There will be a minimal amount that actually kind of like bind to the sides of the glass, so it won't like pour out and be completely dry, but they don't really affect the measurement that much.
That's what happens whenever you pour like it on glass or on yourself, because when you see it, some of it just like rips off, some of it's like little drops on you.
Yeah. Yeah. Okay. Oh yes, Ethan.
When a cup gets too full, you can see it go over the edge, but it doesn't fill out. Why?
Oh, you mean when it like bubbles up a little bit?
No, like when the actual liquid is over the. So you have the cup, and the liquid goes over the edge, and then how come it doesn't fill out?
Because it's a great question. Sometimes, so for example, water. Okay, water molecules have a tendency to bind together. Okay, it's the same reason why you have a water droplet, basically. So as you fill it up, right? As you fill it, if it goes just a little bit above, there is a certain point where the water molecules will actually like kind of stick to each other and form more like a bubble shape. Eventually, once you add too much water to that, it can't hold that much, and that's when it spills over. Does that make sense? It's kind of the same thing with like a water faucet. Okay, you know how you have a water faucet that's dripping. Okay, sometimes you have like the water faucet, like if this is the bottom part of it and the water comes out here, right? As the droplet starts to form, it makes like a bubble shape like that, right? And then as it eventually gets bigger and bigger and bigger, and it's like hanging on, and then it gets a little bigger, and then it gets a little bigger, and eventually it like actually falls all the way off. You know what I'm saying? That's because those water molecules have like somewhat of an attraction to each other. So they bind together, but once this gets to be too heavy, it breaks that bond, and that's when it falls down. Same thing with the cup. Okay? Alright. Moving on to gas state. Nope. Alright. A gas state of matter. Gas is a state of matter in which the matter does not have a definite volume or a definite shape. the size of it is constantly changing, and the shape of it is constantly changing. Okay? Let's go back to the green gas example from yesterday. If someone stuck a pipe under the door and kind of released a green gas into our room, could we measure that size of the gas? Sure. But it would change a millisecond later. If I measure the gas when it's small, real quickly, it will change in a matter of seconds to a much bigger size because it's constantly spreading out throughout the room. Okay? That does not have a definite volume or a definite shape. We can see this with steam. You can see it with air. You can see it with smoke. You can see it with water vapor. Okay? Here are a few examples you could write down. Air, steam, carbon dioxide is in a gas state. Oxygen is in a gas state. Fumes. Fumes from a car, or fumes from a candle, or fumes from a diffuser. Okay? Bubbles in soda. The bubbles that kind of come up out of your soda, that is a very example of a gas trapped in that liquid. The reason why it bubbles up is because it's trying to escape and get out. Okay? Parker.
So why is fire on there? Because when fire is plasma?
Not the fire is not the gas. It's the fumes or the reason that fire is burning on the stove is because there is a gas being released that's being lit. Propane. Okay? Alright. Last one, and then I'll get to your question. Okay? So, the last state of matter is the one that most people are unfamiliar with. It's also the one that we interact with the least. Most of the objects we deal with every day are in one of those three states, solid, liquid, gas. But the last state, a plasma state, is a little bit different. The only part you have to write for the definition is the one in big bold up there. A plasma is very much like a gas, but with free electrons. I'll explain that in just a minute. Definition for a plasma. It's very much like gas, but with free electrons. Meaning the electrons are no longer bonded to the atom that they're supposed to go with. Okay? So, it takes a tremendous amount of energy to be able to knock off the electrons in an atom. Plasma does not regularly occur on the Earth, but it is very common in space. It is what you see when you look at a star, including our sun. Our sun is made of plasma. Man-made plasma, however, is common in the form of neon, like a neon sign. Inside those glass tubes, that substance is in a plasma form. Or even fluorescent lights. The actual light bulb is a solid. It's a piece of matter, right? But the inside of it, what is causing the glow, is plasma. Now, let me explain how that happens. Remember how we drew the diagrams of the different states like this? This would be a solid, this would be a liquid, this would be a gas. You know what I'm talking about? Connor, are you looking? Okay. The atoms, the more that they have, the more energy that's given to them, the further they spread apart, faster they move, right? Well, after a gas state, a plasma is where there is so much energy applied to the atoms that the atoms actually break up. Okay? So, if we took one atom like this, and you zoom in, hopefully you know that an atom is made of protons, neutrons, and electrons, right? Okay. So the middle part of the atom, or the nucleus, is made of protons and neutrons, and the electrons are actually spinning around the outside. Yes? Okay. That is for one atom in a gas. They're far apart, but each one looks like this. A plasma is where there is so much heat applied, or so much energy applied to the atom, that the electron around the outside actually flies off. Okay? And you no longer have an atom anymore. You have a bunch of particles floating around. The movement of the electrons is what causes light or glow. Okay? That's why we don't have an atom model, like one of these, for plasma. Because there are no atoms. Once you break up the electron, now it's no longer an atom. Does that make sense? Yeah. Okay? So this is the fourth state of matter. Kind of uncommon here on Earth, but in space, it is what makes up every single star. Okay? All stars are in a plasma state. Davin?
It also makes up light.
No, lightning is actually light and electricity. It's kind of confusing. They get similar, but as far as I know, it's light and electricity.
We should look it up.
Maybe we will. Ethan H.
So, when you have a glow stick, and it's like not cracked yet,
Mhm.
and then you crack it, well, like you crack it to where it glows.
Mhm.